Something shifted in 2026 that nobody fully prepared for. Humanoid robots stopped being impressive and started being unsettling. Not because they look dangerous, because they look competent. Atlas is doing football moves and lifting refrigerators alone. Figure 03 worked a warehouse shift for over 200 hours straight on live camera. Unitary G1 is responding to voice commands in real time. Tesla is converting its Fremont factory floor for Optimus production. Matrix 3 can feel a piece of fruit without crushing it. And a robot in Shanghai just walked a fashion runway like it belonged there. The line between machine and worker is disappearing faster than anyone expected. Let me break down exactly what happened. Boston Dynamics School of Football series with Hyundai looks like a FIFA marketing campaign, but it quietly showcases one of the biggest robotics breakthroughs of the year. Atlas studies World Cup footage, replicates dribbling drills, performs celebrations, and even executes a clean Rabona, one of football's most difficult technical moves. What makes this remarkable is that this is the Enterprise Atlas, a robot designed for industrial factory work, not sports. The same machine was recently shown lifting a mini fridge weighing over 100 pounds, rotating 180 degrees, and placing it down without losing balance. Atlas was primarily trained on loads between 50 and 70 pounds, yet handled the heavier object because it wasn't replaying a scripted motion. It was adapting in real time through proprioception, its ability to sense weight, force, and body position internally. The hardware is equally impressive. Atlas uses only 2 actuator types across its entire body, with identical arms and identical legs. Boston Dynamics eliminated cables from every joint, removing one of the most common causes of robot failure. Major components are modular and can be replaced in minutes, dramatically reducing downtime in factories. Perhaps most important, Atlas now lives largely in simulation before touching real hardware. Engineers vary object weight, friction, and balance thousands of times during training. That is how a robot trained on lighter loads successfully handled a much heavier fridge just weeks ahead of schedule. Atlas is no longer a demo robot. It is becoming a practical industrial worker. On May 14, Figure AI launched a live stream featuring 3 Figure 03 robots, Bob, Frank, and Gary, sorting packages in a San Jose warehouse. The goal was to prove they could handle an 8-hour shift. Instead, the stream kept running for days. During the first 72 hours, the robots sorted roughly 88,000 packages without a recorded failure. When Gary's battery ran low, it autonomously walked to a charging station while another robot seamlessly took over. No human intervention was required. Figure later held a 10-hour human versus robot competition. Human worker Ame Gerard narrowly won, processing 12,924 packages compared to the robot's 12,732. The margin worked out to less than 1/10 of a second per package. The significance is not the package count, it's the transparency. Edited demo videos can hide failures. A non-stop live stream cannot. Every mistake, delay, and recovery happens in public. With millions watching, Figure demonstrated something the robotics industry has rarely shown before: robots performing real work, in real time, for real shifts. Tesla's Optimus program is no longer just about building a humanoid robot. It is about connecting factories, AI chips, software, and automation into a single ecosystem. The Fremont factory is now reworking parts of its Model S and Model X production lines for Optimus manufacturing, creating Tesla's first real test of humanoid robot production at scale. But scaling robots requires more than assembly lines. It requires enormous computing power. That is where Tesla's reported Terafab project comes in. The company is said to be exploring a massive chip manufacturing effort with SpaceX, potentially investing tens of billions of dollars to secure its own AI hardware supply. The goal is simple: reduce dependence on outside suppliers while supporting full self-driving, Dojo, Optimus, Robotaxi, and Starlink from the same silicon foundation. Above the hardware sits the intelligence layer. Grok handles higher-level reasoning. FSD provides vision and environmental understanding. AI5 delivers onboard computing power, while Optimus Gen 3 supplies the physical body and hands. The factory expansion, chip strategy, and AI development are not separate projects. They are pieces of one larger system designed to bring humanoid robots into mass production. Shanghai's Matrix. 3 humanoid robot is designed for one goal: operating safely and naturally around people. Its most important feature is not how it walks, but how it senses the world. The robot is covered in a 3-dimensional woven fabric embedded with sensors, allowing it to detect touch across its entire body rather than relying solely on cameras. This creates a new level of awareness for robots working in human environments. Its fingertips can detect forces as low as 0.1 newtons, making it gentle enough to handle delicate objects like fruit. Each hand features 27 degrees of freedom and tendon-driven fingers modeled after human anatomy, enabling smoother and more precise manipulation of tools, clothing, and everyday objects. Powering the system is the Wave model, a zero-shot learning AI that allows Matrix 3 to interpret new voice commands without task-specific retraining. The robot stands 5 feet, 7 inches tall, weighs 143 pounds, and operates for about 4 hours per charge. With a Shanghai factory targeting 10,000 robots annually and commercial deliveries already underway, Matrix 3 is positioning itself as a serious contender in the growing service robotics market. RLWRLD's box packing demo looks simple. A robot picks up a small box from a moving conveyor belt, orients it correctly, and places it into a shipping container. A second robot completes the pack. The task runs at full speed, fully autonomous, with no human controlling the robots in the background. What makes this significant is what the AI is actually doing. The RLDX1 Foundation model combines video, language, body position, touch, torque sensing, and recent memory simultaneously. The robot is not only watching the box through cameras, it is sensing how the object feels in its hand, tracking how it moves across the belt, and using short-term memory to avoid repeating mistakes. Real warehouses are not clean demo rooms. Boxes slide, belts keep moving, objects shift position. A robot has only a small window to grab correctly, and if the hand reacts late, the entire task fails. RLWRLD claims RLDX1 reached 86.8% success on humanoid dexterity tasks, while a competing model reached around 40%. The system runs at approximately 43.7 milliseconds per step on an RTX 5090, fast enough for live warehouse operations. The company has raised around $41 million in total seed funding with partners including CJ Logistics, aiming clearly beyond demonstrations toward real packing lines, factories, and distribution centers. These robots are not becoming more impressive, they are becoming more useful. And that distinction is what makes 2026 feel genuinely different from every year before it.